In section 6.5, we're looking at proving triangles similar by side, 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 and side, angle, side. This is a continuation of last section where we looked at similarity by angle, angle. So the first one we have is side, side, side similarity theorem. So let's say we have two triangles, one JKL and one RST. And this theorem tells us if the corresponding side lengths of two triangles are proportional, then the triangles are similar. So we're going to write the corresponding side lengths proportional. So that means we have JK is corresponding to RS, so JK over RS. That's equal to JL or KL over ST. And last, JL over RT. So that is my proportion with all three sets of corresponding sides. Now, quick check to make sure those top values, JK, KL, JL, all come from the same triangle. RS, ST, RT, they all come from the same triangle. So you have to make sure they match and we don't accidentally flip one, which could throw things off. So if I have my sides proportional, then the triangles are similar. So we're going to say then triangle JKL is similar to triangle RST. And when we say they're similar, they're the same type of shape, they're just different sizes. We could figure out that size by looking at the scale factor, by comparing those, and we'll look at that a little bit today. So to find similarity by side, 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 we're going to set up this proportion. If it's true, then the two triangles are similar. We don't need to know about angles. We just need that to make it work. So let's look at an example here. I need to see if either DEF or GHJ is similar to ABC. So I'm going to compare these two for similarity, then I'm going to compare these two for similarity. So the first one I'm going to say is triangle ABC is similar to triangle DEF. That's what I'm looking for, a little question mark there. So I need to match up the sides. Now, I have AB and DE are each the first two letters. So that's kind of a clue to what the corresponding sides would be. I like to do that because sometimes it's hard because the shape's flipped around, it's facing other directions, and if we pick the wrong corresponding sides, our answer actually goes off when we could be on the right track. So AB, DE, first two letters, those match up. The second and third letters are BC, EF. So BC, EF, that's 12 over 9. And last we have our third side, which would be AC and DF, which is just our first and last letter. So that'd be 16 over 12. Now, ABC, all the values from that triangle are on top. It's listed first. We want to make sure that order stays. And all the values listed on bottom for DEF are from DEF. So make sure that fits, otherwise it kind of throws off our answer to the scale factor. And so we want to make sure we're consistent with that as we solve these problems. So now if I reduce 8 over 6, I get 4 thirds. 12 over 9 becomes 4 thirds. 16 over 12 becomes 4 thirds. They all equal 4 thirds. This tells us it's true. So yes, triangle ABC is similar to triangle DEF. And that's by side, side, side. If they asked for scale factor here, it would be 4 thirds. Okay, let's look at the next one, which is going to be ABC similar to GHJ. Okay, so I need AB, GH. AB, GH, each the first two letters, so that's 8 over 8. Second and third letters are BC, HJ, so that's 12 over 10. And the last side is AC, GJ, first and third letters. I've matched up all my corresponding sides. I reduce, I have 1, 6/5, and 1. Well, in the last one we said they were similar if they all reduce to be the same. This one does not. 1 does not equal 6/5. They do not reduce to be the same. There would be no scale factor. We're just going to say they're not similar. Now, if I would have tried these two, compare these two, since I know these are similar, ABC and DF, Do you think GHJ would be similar to DEF? Okay, let's look at side, angle, side. It's our second one we're looking at today. So we're going to have triangle X, Y, Z, and M, N, P. So let's work through what we have here. So if an angle of one triangle is congruent to an angle of a second triangle. So we're going to take angle X and angle M. Okay, so that's the first part. And the lengths of the sides including these angles are proportional. Well, sides including these angles, why don't we just think of those as adjacent for right now? Because if it includes the angle, it includes that point, so it would be next to it. So, the sides adjacent to the angles we're talking about. I have XZ, XY, MP, and MN. So those sets of sides need to be proportional. Now, ZY, PN, not going to be used. They're not adjacent to the angle. So I really just need to make two fractions, or two ratios. That gives me that one proportion. So XZ is to MP, XY is to MN. Okay, that gets me to here. Then the triangles are similar. So if I have these angles the same, and this proportion being true, meaning I can make a true statement out of it, then my triangles are similar. Triangle, let's see, X, Y, Z would be similar to M, N, P. So how this is different than side, side, side. First of all, we have an angle, and we don't have a third set of sides. So if I see a problem where I only know two sets of sides, I'm going to look at side, angle, side as one of my options. If I only know one angle and some side values, it's kind of pointing me in the right direction to look at side, angle, side. We need the angle pair, and then we need the proportion to work. So let's look at a couple examples of that. First one, how do we explain how to show the indicated triangles are similar? Well, I have SRT and PNQ. Right off the bat, I look. I don't know ST and PQ, so I don't know a third side. So side, 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 probably not going to work. I have one set of angles, R and N, but I don't really have a way to find the second set. So that means angle's probably out. So really side, angle, side is our option here. Now, it doesn't mean it must be similar by side, angle, side. It just means that's the method we're going to try. If we try it and it works, that's good, it's similar. If it doesn't, then we're pretty much positive it's not going to be similar. We don't really need to go to the other methods to make sure. So let's start with our angles. We know angle R is congruent to angle N, and that's because they're right angles. And then the sides adjacent to those angles need to be proportional. So I have 24 over 18 and 28 over 21. So if this is a true statement, then I have side, angle, side. You have a couple options on how to make sure that's a true statement. You can always reduce. So if I reduce these, 24 over 18 I can divide by 6, and I get 4 over 3. 28 over 21 I can divide by 7, and I get 4 over 3. They match. That's good. It works. Now, sometimes, not particularly this problem, you'll have a hard time reducing. Maybe there's a decimal involved in those fractions, or there's just numbers you're not good with reducing. If that doesn't work, look at cross product. Because if I take this and I do the cross product, I get 24 times 21 equals 18 times 28. And if this turns out to be a true statement, or in other words, I multiply them out, and they still work, it's still true, then it's the same effect as reducing and making sure they're the same. So it's just another method we can have. If you have both of them to use, then you just pick the best one for the problem you're looking at. Well, in this one, I probably would reduce, seeing that the 24 over 18 and 28 over 21 are a little easier to reduce as opposed to multiplying. But if I do multiply, 24 times 21 is 504, and 18 times 28 is 504 as well. They match, it's true, so we know they're going to be similar by side, angle. Oops, try it again. Side, angle, side. Okay, let's look down at the bottom one here. In this case, I have two triangles. They're not facing the same direction. So what I like to do in this case is redraw them separately, turn them so they're facing the same direction, so it's a lot easier to match up the corresponding parts. I do that also because they share a side here, and I want to make sure I put that side corresponding to the right parts in each triangle. So I took XZW, just copied it over here, 20, 12, 16 are its sides, and I'm going to take this triangle and rotate it 90 degrees. That would be counterclockwise. So Y is on top, Z is here, and X is on the left. 15 is my hypotenuse, 9 is between Y and Z, and 12 is between X and Z. So now I can look at it and have everything facing the same direction, and I can see that, okay, maybe even though 12 is here in this triangle, it's going to be down here in this triangle. So we can approach this one two different ways. Side angle side. If we look at side angle side, well, we have angle Z, but let's name it with three letters. WZX is similar to, or it's not similar, the angles are congruent, XZY. Then we have 16 over 12 equals 12 over 9. 16 over 12, let's see, I can divide them both by 4. I get 4/3. 12 over 9, divide them both by 4, I get, or divide them both by 3 in that case, I get 4/3. That matches. These are proportional. So we know triangle XZW is similar to triangle YZX by side angle side. But we have another choice here. You may have noticed we have three sets of sides. So why don't we do side, side, side? So side, 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 if I keep the same that I already copied over, 16 over 12, 12 over 9, and then we just basically tack on the third side, which is 20 over 15, or the ratio of the third sides, I should say. I know these are reduced to 4/3. 20 over 15 also reduces to 4/3. I can divide by 5, so this works. It's proportional. So I know these are also similar by side, side, side. Most of the time you won't have either work, but when we do get that opportunity, we have two ways to get to the correct answer. We should take advantage of that, and either one would be appropriate. Okay, so before you start working on your homework, let's just go through the three we have. This was actually taken from the book. It just kind of puts them all in the same place. We have angle, angle, side, 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 and side, angle, side. How you're going to approach them. If I know just angles, I'm looking at angle, angle. Or there's no side measures or side lengths. So if I look at a problem and there's no side lengths there, they don't tell me any values for the sides, I'm probably not going to use anything with sides because I need to know those sides. If I only know angle measures, well, that can kind of be a little tricky. Maybe they're marked like this one. Maybe they tell me what the degrees are. For example, they're both 40 degrees. They're both 50 degrees. We also have to be aware of, we get vertical angles, reflexive angles, alternate interior angles, corresponding angles. Those show up too, and we have to use those if we get them. More I look for, look, there's no side lengths. I got to look for angle, angle. Okay, side, side, side. Well, I'm going to look at side, side, side as a way to solve if I know three sets of side lengths. It'd be pretty easy to look at the problem from the beginning and notice that you know all three sets of sides on each triangle. If you do that, write the proportion, plug them in, and try to get your similarity. Yeah, it won't have any angle measures. We'll be more focused on the fact we have three sets of sides, and that kind of makes our job a little easier. Third, we have side, angle, side. So we've looked at a problem. You don't have just angles. You don't have just sides. You kind of have a combination of both. You're going to use side, angle, side if you know two sets of sides and the angle between them. And when I say the angle between them, that's the angle they share. The angle they share between them, it's where they meet. AB and AC meet at A. That's the one between them. So, another way to think, you don't have that third set. If you only have two sets, you can't do side, 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 you must do side, angle, side. So, I like to take it now, we can look at the problem we have and pretty much pick from the beginning which one we're going to try. This is nicer than congruence, where it was, here's the problem, work our way through and eventually find it at the end. So, look at your problem you do, plan out which one you're going to try, look for your two sets of angles for angle, angle, try to get